My name is Stefan Oehme. I lead the performance team at Gradle. And in this talk, I'm going to show you how to profile your own builds to achieve the maximum build performance that we've been talking about so much in the keynote. And this talk was a lot of fun to prepare, actually, because I got to break every Gradle performance rule on the way and created a project that's an abomination. So it was amazing times. And we're going to fix that project up using the profiling tools that Gradle provides to you. OK, so first question, of course, why should I profile? And for some, that might be completely obvious, especially if I look at the Android community on Twitter, then they are very vocal about that things are too slow, or at least were until very recently. But even if nobody's complaining in your organization, things might still be costing you a lot of money. Just think about that. If you just wasted, let's say, 30 seconds on an incremental build, which is really a lot of time, 50 builds per day for 50 developers, you're wasting 21 hours in just pure waiting time. And that's not even taking into account all the lost focus that's caused by that. Because really, 30 seconds means the developer is long gone on Twitter or emergency kittens or whatever. So this really adds up to probably 100 hours of waste. So that's like 5 people sitting in your office, 5 of 50, so 10% of your workforce sitting in the office twisting thumbs. Would you accept that if you walked into the office and you just saw those 5 people sitting around the table being like, yeah, that's what we do here? You probably would be furious. But somehow we sometimes accept it with our automation, and we shouldn't. And it's not just the waste in time. Every developer who truly likes developing will attest that waiting for 30 seconds is painful. I definitely wouldn't want to work like that. If it took me 30 seconds to verify some bug fix to some sub-project of Gradle, I would probably quit. Well, no, I would fix it, but if it was out of my hand, if I'm a developer, I'm not on the build engineering team, and fixing the build is out of my skill set, I would probably consider quitting if every little change I do takes 30 seconds to verify or longer. So you might also lose a lot of talent that way. So you really want to make sure that that doesn't happen. But how do you know there is a problem, especially if people don't directly approach you and punch you in the face because it's too slow? Well, that's where Gradle Enterprise comes into play. With Gradle Enterprise, you can collect data of all the builds that are happening in your organization. So not just traditional CI builds. I mean, CI servers have done that for a long time, showing you simple statistics of how long the builds took. No, also local builds from all your developers. So you know exactly what they're doing. You can see trends. You can see what are the tasks that they're struggling with the most. What's wasting most of their time? I mean, surely there's a lot of things that you could improve about your build, but where to start? What's the lowest hanging fruit? Yeah. With Gradle Enterprise, you can find out. You can see what your developers are doing and optimize the most important thing. So let's take as an example, I was looking for people who did a local build and ran clean. Because you really shouldn't be doing that, right? Gradle isn't Maven. We have incremental builds. So I see here that my colleague Will apparently is running clean a lot. And that might point me at the problem that maybe he needs to be educated. Maybe he just doesn't know that you don't need to call clean for a reproducible build with Gradle. Maybe he just doesn't know. So I should just tell him. Or maybe Will is actually having a problem with the build. I screwed up, I wrote a task, and it's not properly incremental, it's failing on incremental builds, and he is just doing the sensible thing and working around it, wasting a lot of his time. If I didn't see this data, I would never know that this is happening. So once I've identified some interesting scenario that seems like it's taking too long, I can dig in, and I can look at the build scan and see what's taking the time. There's a performance breakdown of all the build phases. There's a timeline showing you which tasks were executed, if they were executed in parallel, what was the longest task, what's bottlenecking your build. And you can really find out very quickly what's the low-hanging fruit? What should I be optimizing? And one of the coolest features, and I used to have my own slide here, but after I saw the keynote yesterday, I quickly replaced that with the example from Tableau, because it's way better than what I had. You can export from Gradle Enterprise to your favorite business intelligence tool and then graph that data to see trends. So for instance, what happened at Tableau is there was a problem with check style, and it was taking a long, long time to run. But for some reason, nobody bothered fixing it. People had just accepted, yeah, check style takes half a minute every time we run a build. Terrible. And even, you can see that spike. Somebody actually broke it even more. But since everybody had given up on check style, they were like, yeah, well, now it takes a minute. Well, who cares? So after fixing it right away, they could see how much they had saved. So they could make a clear business case. They could go and justify, we're going to spend 2-3 engineering days figuring out that problem because look at how much it's costing us. And after they fixed it, they could go to their superiors and say, look at how great I am, what I just did for this organization, let's talk about salary. So it's a great tool to really think about what should I be doing, what is the biggest impact I can make on my organization. All right, so you found that there is a problem. You know, people are struggling with this task, or incremental assemble is taking too long. Now, how do you know where that problem is coming from and how to fix it? So in order to showcase that, I created this example project that's on GitHub called Analyzing Gradle Performance on my GitHub account. It has 100 subprojects. Most of them are empty, actually. They're just there to exaggerate some problems that this build is having. Most of the code is in 3 projects. It's 1 million lines of code and 50,000 tests. So it's a pretty sizable app, but not too crazy. It's like what we at Gradle call a medium project. Our big performance test projects have 10 times that amount of code. And I deliberately made this start out with Gradle 2.14.1 because according to our statistics, quite a lot of people are still using that. And I committed every performance crime I could think of. I also polled the team and said, hey, do you have anything else to add to that? What else could I break here? So it was great fun. The result was I ended up with a 4-second configuration time, which is terrible, but according to what we've heard from partners, it's far from the worst that we've seen. So we've seen things like 10, 20-second configuration times. One particularly pathological example was 2 minutes configuration time. I don't even know what to say about that. A single line change took 25 seconds. So just imagine you change a method body and you click run, and then you have to wait almost half a minute to know whether it works. Terrible. And the clean build is 55 seconds, which doesn't sound so bad until you realize how fast it could be. Okay, so how do you figure out where the problem is? For that, we should first talk about what are the lifecycle phases of Gradle so that you can focus on individual chunks of your build. Gradle's lifecycle is broken down into a few phases. Startup, which is we're starting up the Gradle client, might be the tooling API, might be a command line client. We connect to the Gradle daemon. We evaluate your settings script that lists what projects you want to have. We configure those projects. Then we select the tasks that need to be executed according to what the user specified on the command line, and then we run those tasks. And each of those phases has different recommendations of what could go wrong there and what you could do to fix it. So let's start with some general phase agnostic advice. The very first thing you want to do is please always stay up to date with the latest Gradle versions. Really put some effort into this, because if you don't, you're missing out on so much performance goodness. Like, my performance team has been working so hard to make performance great again. And if people don't upgrade to 4.0, the last 6 months would be going to waste, basically, and that would be very sad. So really always stay up to date with the latest minor release. We put a lot of effort into keeping minor releases compatible. It's a very, very strict regimen at Gradle. So as long as you keep those minor versions up to date, you will see deprecation warnings coming up for the next major release. So you will know if your build is doing anything that will no longer work in the next major. And we don't break anything that we haven't deprecated before. Now that might be actually not in your build, but in a community plugin, in which case really nag those plugin authors. If they care about their users, they will fix it. And the vast majority of them does. Now, Gradle 4.0 is a really exciting release. We, for instance, have a much, much faster dependency resolution, parallel downloads, parallel fetching of metadata. Of course, the build cache is much improved and production ready. So it's a really amazing release on its own. And it also enables the new Android Gradle 3.0 plugin, which we've talked about a lot with its variant-aware dependency management. So Gradle 4.0 is really a big milestone in terms of performance. It's definitely upgrade. Now, once you've done that, you want to look out for some red flags in your build. So startup time bigger than 1 second, that's a problem. Configuration time bigger than 1 second, that's probably a problem. Unless you have like 1,000 subprojects, in which case 2 seconds might be okay too. If you have 10 seconds, it's kind of unacceptable. We have a test project actually on CI. It's run on every commit. It has 500 subprojects with the Java plugin, IDEA plugin, Eclipse plugin, et cetera, and that takes less than 1 second to configure. So if you have only, let's say, 100 projects and you take more than a second to configure, there's something wrong. There's some plugin in your build or some build script that's doing something it shouldn't. A single line change taking more than 10 seconds is kind of a red flag. It basically means one of your developers does a single line change, clicks run, and has enough time to get distracted. Like 10 seconds is kind of the threshold where people start going on Twitter or checking email, etc. Below 10 seconds, it's kind of acceptable. You'll still stay focused and kind of be excited and follow along on the progress of your build, but beyond 10 seconds, you've lost your developers. So really try to stay below that. And another red flag is if you do a build and then you change nothing and do the exact same tasks again, and there's any task that's executed, that is also a red flag. If your no-op build does any work at all, you need to fix something. And we'll see what the problem could be in a second. Now, of course, you want to keep measuring your performance over time, and you want to work together with your colleagues and discuss performance problems together. And it can get confusing very quickly. Someone might say, oh yeah, a single line change takes 20 seconds. And then you try to reproduce it and say, well, for me it takes 5. What did you change? How many warm-up builds did you run? What other command line arguments did you pass? And you know, that whole back and forth. You don't want that. You want a tool that automates all of that for you. And that's why we built the Gradle Profiler. So you can just get that on GitHub, install it on your machine, and it supports this configuration file syntax where you can say, here are my performance scenarios. So before you even jump in and try to optimize stuff, you want to define the scenarios that you care about. For instance, I've seen on Gradle Enterprise that my developers are calling incremental assemble very often. So I want to focus on making an incremental assemble fast. So you can define a scenario that says, run the assemble task after making a non-ABI breaking change to this file. And do 10 warm-ups, please, and use the -- build cache flag, for instance. You can automate all of these scenarios, and then the Gradle Profiler will run them for you, produce a nice report of how long it took, what the standard deviation was, etc. And it also supports all the major JVM profilers. So if you need to go down to the method level, let's say you've implemented a custom task, and for some reason that task is inefficient, but it's just on the algorithmic level that you found the inefficiency, then you need to go and profile that task. So the Gradle Profiler also integrates with JProfiler, YourKit, JFR, etc. So you can get low-level method details. Okay, so you've set up your profiling pipeline and you've created build scans for the scenarios that you care about. You can also automate build scan creation with the Gradle Profiler, of course. So you can say, I want to create build scans for the ABI change scenario, for instance. And now we're going to go through the different phases and see what you could do about them. So startup. What can you do about startup? Not much, actually, because that's all in Gradle itself. The one thing that you want to keep an eye out for is whether your builds are using the daemon and if that daemon is healthy. So if you see here, the age of this daemon is 16 minutes and it's been running 15 builds before that one, so everything's fine. If you see the age of this daemon is basically 0 and no other builds were run, then this is a fresh daemon. And a fresh daemon means we have a bunch of code that just got compiled by the JVM, so we were running a lot of unoptimized code, which makes our build slow. It also means Gradle needs to load a bunch of caches from the file system back into memory, which takes a lot of time. And so you want to make sure that your developers are using the daemon, which is the default since Gradle 3.0, and that those daemons are healthy. So why could they be unhealthy? Well, for instance, you could be having many different builds, and if you use many different Gradle versions and also maybe give them too much memory, then they might be fighting over system resources. So there might be 5 daemons because you're using 5 different Gradle versions and you give each of them 8 gigs of RAM. Then each daemon will go and start and tell the other ones, hey guys, I need some memory here, shut yourself down please. And then the next time you build another project, the same thing happens. So just keep an eye out if this kind of thrashing is happening to you. Otherwise, there's not much you can do about startup. A warm daemon is all you need. And the next step is configuration time. And there's lots of juicy advice that you can get from build scans here. So let's just talk about what exactly is in configuration time. Configuration time comprises applying your plugins. So let's say apply plugin Java, IDEA, Nebula Lint, or whatever. Evaluating all your build scripts. And after that, running any after evaluate blocks. So a common misconception is that after evaluate is somehow lazy. It's not. It just comes later. Hence the name after evaluate. It comes after evaluating the build scripts. But it is still part of configuration time for every project. So all the after evaluate blocks will be run for every project during configuration time. And when is configuration time run? Well, every time. No matter which task you run, even Gradle help and Gradle tasks, or when syncing your project with IntelliJ or Eclipse, the project needs to be configured to get the model, or it needs to be configured to see which tasks are there and which tasks we need to run. So having problems in configuration time means that your developers are suffering no matter what they try to do with Gradle. Luckily, the latest BuildScan version and Gradle Enterprise version will give you a really nice breakdown of configuration time and things happening there. And the very first anti-pattern that I want to talk about is dependency resolution at configuration time. Why is that bad? Why is it bad to resolve dependencies at configuration time? Well, you don't know if you're going to need them. You only need those dependencies to run certain tasks. So why would you resolve them no matter which task you run? It's probably wrong. Like 99.999%. I've seen one plugin that had kind of a use case for it, but could have done it differently. But otherwise, it's wrong. Don't do that. You don't want to resolve dependencies that you might not need. How do you spot it? You just click on the dependency resolution tab in your build scan, and you see a breakdown between project configuration and task execution. So in this project, there's 170 milliseconds spent, and it also tells us my app runtime is the one being resolved. So we look into the build script of my app, and we find this little friend here. The most upvoted answer on Stack Overflow for how do I build a fat jar. And unfortunately, I only have one downvote on Stack Overflow. So what this is trying to do is package the main sources into my the main outputs, so the main classes, into a jar, and then package all runtime dependencies into a flat structure. So it's going to go and take all the classes folders and unzip all the jars on my runtime configuration and package them all into one jar. Why is that wrong? Well, the groovy collect method is not lazy. This is eagerly evaluating. So this is going to go at configuration time, resolve all my runtime dependencies, unzip them at configuration time, and then I'm just probably not going to run the uberjar task. I'm just syncing with IntelliJ, or I'm just calling Gradle help. So I've just gotten did a bunch of downloads, did a bunch of unzipping, and then didn't use it. Terrible. So how do I fix it? It's actually very simple. Everywhere where Gradle accepts a file collection, it'll also accept a closure that returns a file collection. So I can just say, hey Gradle, the input is this piece of code that will eventually return a file collection when you need it. And there's only one caveat to that. Since this is now wrapped in this lazily evaluating closure, Gradle doesn't know what's in there. Gradle doesn't know that your task depends on the runtime configuration. So you need to rerun that task when the runtime configuration changes. So you need to tell it about it. You need to say, hey, Gradle, the input files for this task contain configurations.runtime. And then Gradle will go and make sure that all the projects that are in your runtime dependencies are built before you try to run that uberjar task. Now this is the other tab in the project configuration breakdown. You can see a breakdown of your configuration time by project, and then you can even expand that. We'll see that in a second, to a lower level and see how long each script and each plugin took to be applied. So here we see that the My App project build script has a self time of 240 milliseconds. That's quite a lot. Why is that? Well, we could now take the Gradle Profiler and go and run a method level profiling and see, oh, there's actually some file writing going on. There's some file I/O there. Why? And I found this little gem. What's wrong with this? Anybody? Yeah, so this closure is configuring the task. But what am I really doing? I'm writing some file. It's a typical beginner mistake, but it even happens to experienced developers from time to time, just forgetting the do last block. So what we wanted to do is tell Gradle, hey, this task is going to do this writing when you run it. But we accidentally made it right during configuration time. So we just tell it, okay, these are the inputs, these are the outputs, and this is what you should do at runtime. Now, I personally don't like this style. It looks a little spaghetti, and also it disables caching if you have these ad hoc do last blocks. So what you really want to do is write a custom task. Yeah? Clearly define, okay, it has a source input file collection, it has a output file called the stats file, and the action is writing something to that file. And then in my project's build script, I just say, Gradle, please create me one of those project stats tasks, and the sources is source main Java, and the output file is stats.txt. So a much nicer separation of concerns. And that way, there's no way that I can accidentally break configuration time because it's clearly separated. The heavy lifting is in the task action. There's no way to mess it up. So always prefer custom tasks. Another thing that I see very often is inefficient plugins. So plugin authors often don't keep in mind that their plugin might be applied to 100 or 500 sub-projects. They test it out with a single project and everything works fine. And then people start using it in the wild and it's actually terrible. So I've emulated that here with a plugin that goes to Git and says, hey, can you please tell me the current revision that I'm on and assign that to my version. So my version equals the revision, the Git revision. And it does that for every sub-project. So as I said, I have 100 sub-projects here. And for every one of those sub-projects, it spends just 7 milliseconds, which doesn't sound so terrible, right? So the author of this plugin probably tried it out on a single project build and didn't see any noticeable slowdown, so everything's fine. But if I have 100 projects, that's almost a second only for this thing. So if we look at the source code for that plugin, we see immediately, yeah, it's doing an exec, capturing the output of Git, and then assigning that to the version. And then the user of that plugin just said, apply it to every sub-project. And that's how that performance problem came to be. How to solve it? Well, the plugin authors should probably have designed it the other way around and said, either I apply to every subproject, but I only do the calculation once and cache it somewhere, or I tell people that it should only be applied to the root project, and I iterate over the subprojects myself and go and assign the version to what I just computed. So one way or another, do it once, reuse the result is the moral of this story. Okay, so these were the configuration time problems. I have a bunch more in the real example project. You can look it up on GitHub, and then on the after branch, there's a commit for every problem that was fixed. So there's a bunch more examples of typical things that I found on Stack Overflow, but these were the most painful. So execution time consists of selecting the tasks that I need to run. So the user says assemble. Well, what does that mean? Okay, I need to compile Java, I need to process resources, etc., etc. Gradle will run those tasks incrementally, so it will only rerun those tasks whose inputs actually changed. It can parallelize tasks, and up until now there was only the -- parallel option that we'll talk about later, but you also heard in the keynote, or if you visited Gary's talk, that we have a new API for safe parallelization by default, which will be used throughout Gradle very soon, which means that most of your builds will actually parallelize quite well out of the box very soon. And of course, our tasks are also cacheable. There's dedicated talks on that, so I won't go into detail here. But it means that you can reuse build outputs across machines even. So your CI server builds something, your developers come into the office in the morning, do a git pull and a Gradle build, and it takes 2 seconds because the output was already built by the build server. Okay, so what can go wrong with incremental tasks? Well, what I did was I did a completely up-to-date assemble. I didn't change anything and called assemble 2 times in a row. And it still took how much? Almost 8 seconds, more than 8 seconds. So there's something really wrong here. It shouldn't be doing anything. So I look at the timeline, and the timeline view not only shows me which tasks are executed and how long they took, I also can open a details view on the timeline, and will tell me this task was not up to date because of the following reasons. The value of the input property timestamp has changed for my app compile Java. So somebody actually put a timestamp into this task's inputs. Well, no wonder it's not up to date. And that's actually very, very common. So this is something that I've seen in a lot of builds. For instance, the JUnit 5 team did this kind of thing, and lots of other open source projects as well. Put a timestamp in our manifest. Why? Well, might be useful if we need to debug an issue. We can look, when was this built? Is this the right version? I'm not sure if a timestamp really helps more than having the version number in the jar, but who am I to judge? But for developer build, do you need a timestamp in your jar? Is your developer like, does he not have object permanence? She built the app and then forgot all about it and is wondering what's broken? No, it doesn't happen, yeah? So you don't want that. So what can you do? Well, a very simple workaround is make development the default mode. Skip any kind of work or any kind of inputs that should only be changing on production builds, basically CI builds. You can detect pretty much every CI server through some environment variable, either by setting it yourself in your automation stack, or many CI servers already have unique environment variables, like Jenkins has a job ID environment variable, TeamCity has a TeamCity build ID, etc., etc. So you can pretty easily tell that you're running on your build server. And if you're not running on your build server, well, then you just assume it's a developer build. And on a developer build, you just say, I take a constant here for that date. Yeah? So everything stays compatible, like any code that might be reading that manifest entry will still work, but it'll just be a constant. And that way, my task will always be up to date on developer builds. So this is a special case of a more general topic, which is specify exactly what your tasks need. No less, because otherwise they will be up to date when they shouldn't be, which is terrible, because then your developers will perceive your build as broken, and they will start running clean builds again. But you also shouldn't specify anything that's not needed. So don't let your task depend on some other task whose output it doesn't really need. Only depend on what you need. Don't put any input properties that are only useful for production into your developer builds. Specify as little as possible. That way, as little as possible will get executed. Now, you did do that, but still every change rebuilds a relatively large chunk of your app. Probably means that you need to break down a monolithic project into a few sub-projects. So if you have a single project with 50,000 Java source files, and you make a change, and you're in the unlucky position that you're using annotation processors, so Gradle has to switch off its incremental Java compile feature, then you're going to recompile 50,000 source files, and that's going to take a long time. If, on the other hand, you break that down into, let's say, 50 modules with 1,000 source files each, then you're going to have a much faster compile, because then Gradle only needs to recompile the code of that one module if it was a internal change, or that module and everyone who depends on it if it was an API breaking change, but not anything else. So breaking down your projects into smaller modules is always a good idea. There is actually a whole talk on the topic of maximizing incrementality for Java projects. My colleague Cedric Champeau will give that in the last slot today. So if you want to learn more about how to optimize your Java projects for maximum incrementality, you want to go there. There's also a blog post in case you can't make the talk. You can either watch the recording or read the blog post that Cedric wrote a while ago. Okay, so another benefit of breaking things down into smaller modules is that you could parallelize them. Just look at this timeline here. We were spending 40 seconds for doing a clean install on Gradle itself. So this is the Gradle repository. I did that build yesterday evening. And I did a clean just to see what the effect would be. And it took 40 seconds to recompile everything. We have about 100 subprojects. The longest steps are Groovy compilation and some external module patching. When I run the same build with --parallel, it goes down to 28, which is a pretty nice speed up. And you can see really nicely in the timeline what the bottleneck is. So there's this one big task at the end called patch external modules that's dominating. So we might want to do something about that next. The caveat is --parallel can only be used if your projects are completely decoupled from each other, which means they cannot influence each other at runtime at all. So typical case where that breaks down is you have integration tests. They hit the same database and delete stuff that that one test is creating. The other one deletes it, and then the first test wants to read it, for instance. There's ways to work around that. So if you can design your tests in such a way that they use unique IDs so they can hit the database at the same time without interfering with each other. But if you're not at that point yet, then you can't use --parallel, which is unfortunate, and which is one of the main reasons why we went to build the worker API, which is a much safer way of parallelism, because we can say on a per task level, this is going to do this kind of background work. Other tasks can run once we're just waiting for the background work. And we will also enable users to say, hey, these test tasks here, they need this database, and they need an exclusive lock on this database. And then Gradle will take this into account at task scheduling and make sure that everything's safe. So you will benefit from a lot of parallelism, even if not everything in your build is parallelizable, which is much better than the old --parallel option, which will die eventually once the worker API is used everywhere. So if you're in the unfortunate situation that you can't use --parallel and the worker API is not fully rolled out yet, but you want to make at least some step forward, then for most builds, testing is the most expensive step. And a lot of your test tasks might actually be decoupled, especially unit tests are usually completely independent from each other. In that case, you can just tell Gradle to fork the tests in parallel. So just run 4 workers instead of 1 and push tests to each of them. That gives you at least some parallelism. One of my favorite aspects about kind of the fear and uncertainty spread on the internet is memory usage of Gradle. I told you about this big, this big 100 module build, this analyzing Gradle performance build, has 100 subprojects. How much memory does it take? Well, not even 500 megs of RAM. Yeah. We have a large 500 module Java project, and that takes barely 1.5 gig. So really scrutinize your memory usage and give Gradle an amount that makes sense for your project. Look at the build scan. You'll see what your max heap usage was. You'll see how much time was spent in garbage collection. If you're close to the max and you see lots of GC time, then you'll need more memory. If you're nowhere near the maximum, then you're really just, well, first of all, wasting system resources, but you're also increasing your GC pauses. Because the bigger your heap is, the longer a full GC takes, because the JVM has to walk that whole heap. So really set a reasonable amount. And if you have like a monolithic project, like you have 10 subprojects and one of them contains most of your code because you're migrating away from a monolithic setup to a more evenly spread out multi-project, maybe some legacy code base, then you can tell Gradle to fork this one compile task, and that will basically move the expensive compilation that's dominating your GC time to a different process. And then it won't affect all the other compile steps. Eventually, this will become the default. So we're currently improving the worker API. So again, this is another problem this will solve, to actually let those worker daemons live as long as the main Gradle daemon lives. So if you've compiled on 4 different compile processes, then we'll just keep them around. Until now, we just kill them off at the end of the build to free up system resources. But that will change. We'll keep them around. We'll shut them down if you actually need your system resources. But if you don't, we'll keep them alive because you'll probably run another build soon and you'll need them. They'll be warmed up and performant. Okay, so you've optimized your build scripts and you've specified the minimum inputs. You've optimized your build time, and you want to make sure that it doesn't regress again. You want to make sure that you will be able to find problems more easily in the future. Or maybe you have a problem, but you don't know exactly where, and you want to make it easier to find. So how do you make your build logic a little more manageable? A first recommendation is split your builds into script plugins. So don't have this like one root project that has 1,000 lines of code configuring everything, every aspect of your automation. Split it up into smaller scripts and apply them. It makes it much easier to find issues because build scans will tell you the time was spent in foo.gradle. Next step, if you have any kind of complex logic, don't leave it in a script plugin because dynamic Ruby is pretty slow, and also if you have complex logic, you probably want to test it. You don't want to leave the correctness to chance, like somebody accidentally finding a problem that you had in your calculation. So if you have any kind of complex imperative logic, put it into buildSrc. Don't put it into a script. And then in buildSrc, you have all your normal plugin development tools at your disposal, so you can use Gradle Test Kit to actually write functional tests for your custom tasks. And you can make sure that your project will build correctly without having to try a full clean build of your app. You can just run a simple test. And when you're in buildSrc, make sure you're statically compiling your plugins. So don't write them in dynamic Ruby. If you're using Groovy, use @compile_static on your classes. Otherwise, write them in Java, write them in Kotlin, or whatever static language you prefer, but don't use dynamic languages to write your plugins. It's too slow. And if you're having a problem with one of your tasks or one of your plugins being slow, and it's a too low level problem that build scans could show you, let's say you have some resource processing task that just has some very expensive algorithm, then you can use the Gradle Profiler to run with any of the big commercial profilers like JProfiler or YourKit to get a method level overview of where your time is spent. So that's a great way to debug your own build logic. And it's also a great way to report problems to us, of course. So let's look at the results. Let's look at before and after for this project, after applying all those best practices. Configuration time. We're done. On the left side, you can see we're starting a new Gradle daemon because this was Gradle 2.14.1, and the daemon wasn't the default. So this is the experience that people have that are still not using the daemon. That project took about 6 seconds to start up and configure all the subprojects, whereas on the other side, we have about 500 milliseconds plus 500 milliseconds for starting up the command line client. If you're running from the tooling API, you save those extra 500 milliseconds for starting up the command line client, so that project would be even faster. So when you work from IntelliJ or Eclipse and you double click on running some task, it's even faster than that. A single line change. How much would that take? 2 seconds with the optimized version. We're just recompiling exactly what is needed and nothing else. Whereas on the left-hand side, well, I almost want to click to the next slide because this is so painful. We're going to rerun almost everything just because there were some evil timestamps in there. And finally, the clean build, which is also funny because we could almost execute 2 clean builds of the new version in the time it takes the old version to do a clean build, just by optimizing our memory usage or the memory that we assign, by using parallel execution, and by removing some unnecessary work. And by the way, I really love the new console output. So much cleaner, as you might be noticing by now. There's so much useless information on the left side. Oh yeah, I executed this, I executed this. Well, yeah, sure, I told you to. Obviously, you're doing that. Whereas on the right-hand side, I'm only seeing what I really care about, which is what is Gradle currently doing and when will my build finish. Now, I know this was a lot of information in a very short amount of time, so you can, of course, find slides online, but we also have a bunch of resources for optimizing your build. We have a performance guide that talks about all these issues. We have a plugin development guide that gives you best practices on how to write plugins efficiently. And we have a user guide chapter about structuring build logic to make problems easier to spot and just to make your build scripts more readable, really. If you have any performance-related problems and you want to ask a question how to do things right, just go on discuss.gradle.org. And if you have optimized your build and you think there's nothing left on your side that's slowing it down, but it's still too slow, just send us a JProfiler or YourKit snapshot. Open a bug on GitHub, attach the snapshot, or if it's confidential, you can also send it to performance@gradle.com and we'll look into it. It's not a support channel, so don't expect an answer anytime soon. But if we find that this is actually a problem in Gradle, then we will just fix it and make it better for everyone. And that's all I have. Thank you very much.